Good day, everyone. Welcome back to the continuation of our discussion on the topic application of differentiation. Today, we'll be discussing rate of change. Our very first question is from UME. It states that if the volume of a hemisphere is increasing at a steady rate of 18 pi meter cube per second, at what rate is its radius changing when it is 6 meter? That is, we are looking for the change of the radius of the hemisphere given the rate of the change of the volume of said hemisphere. And we know that the formula for looking for the volume of a hemisphere V is equal to 2/3 pi radius cube. Now, to find the rate of change of the radius, it is important to note that the rate of change of the volume with time is equal to the rate of change of the volume with respect to the radius times the rate of the change of the radius with respect to time. That is, dv over dt is equal to dv over the arrow times the arrow over dt. Here we are given dv over dt as 18 pi meter cube per second, and we can get dv over the arrow from differentiating our formula for the volume of an hemisphere. Now, the volume of an hemisphere V is equal to 2/3 pi arrow cube. Now, the V over the arrow, that is differentiating V with respect to arrow, will be equals to 2 pi radius square, that is 2 pi arrow square. Now, at the point where arrow equals to 6 meter as given in our question, the V over the arrow will be equals to, at this point we'll be substituting arrow to be equals to 6. So that is 2 pi in bracket 6 squared. And simplifying, the V over the arrow will be equals to 72 pi. Now, our next step is to substitute for dv over dt and dv over the arrow. In our formula, we say that dv over dt is equal to dv over the arrow times the arrow over dt. Doing so, 18 pi, which is dv over dt, will be equal to 72 pi, that is dv over the arrow, times the arrow over dt. And to get the arrow over dt, we are going to be dividing both sides by 72 pi. Dividing both sides by 72 pi, 18 pi divided by 72 pi will be equals to the arrow over dt. Dividing 18 pi divided by 72 pi, that's 1/4. Therefore, the arrow over dt will be equals to 1/4, or 0.25 meter per second. And the correct answer is C. Our next question is from UME, and it states that a circle with a radius 5 cm has its radius increasing at the rate of 0.2 cm per second. What will be the corresponding increase in the area? Now, since it's a circle and we know that the area of a circle is equals to pi radius square, so this will be the main function in this our question. Now, to get the a over the t, we are told that the a over the t is equal to the a over the arrow times the arrow over the t. That's from our previous knowledge and our previous question we've solved. Hence, we are looking for the a over the t, and to do so, we need to find the value of the a over the arrow and the arrow over the t. Now, in our question, we are given the arrow over the t to be equal to 0.2 cm per second. And to get the a over the arrow, we are going to be differentiating the area with respect to arrow. That's what differentiating a with respect to arrow. Writing down our formula for the area, a is equal to pi radius square. So differentiating with respect to arrow, the a over the arrow will be equals to 2 pi arrow. Now, at the point when arrow equals to 5 cm, we'll be substituting arrow for 5 in our d over the arrow answer. Doing so, the a over the arrow will be equals to 2 pi times 5, and multiplying, the a over the arrow will be equals to 10 pi. Now, we know that our value for the a over the arrow is 10 pi and the arrow over the t is equal to 0.2 cm per second as stated in the question. We will be substituting for the a over the arrow and the arrow over the t in our d a over the t formula. Doing so, the a over the t will be equals to 10 pi, that's the a over the arrow, times 0.2, which is the arrow over the t, and multiplying them, the a over the t will be equals to 10 pi times 0.2, which is equals to 2 pi, and the correct answer is B. Our very next question is from PCE 1992. It states that the radius of a circle is increasing at the rate of 0.4 centimeter per second. Find the rate of increase in centimeter square per second of the area when the radius is 5 centimeter. Now the main function here is the area of a circle, which is A is equal to pi radius square, and we know that to get the A over the T, it will be equals to the A over the arrow times the arrow over the T. Our call of duty is to find the A over the T at the point when the arrow over the T is 0.4 centimeter per second. Now writing down the area, A is equal to pi radius square, we are going to be differentiating the area with respect to arrow. That is, we are going to be finding the A over the arrow. Doing so, the A over the arrow is equals to 2 pi radius. And from our question, we are told at the point when arrow is equals to 5 centimeter. Now when arrow is equals to 5 centimeter, we'll be substituting arrow for 5 in our the A over the arrow. So doing so, the A over the arrow will be equals to 2 pi times 5, which is equals to 10 pi. Now we've gotten our value of the A over the arrow, and we know our the arrow over the T to be 0.4 centimeter. Now substituting for the A over the arrow and the arrow over the T in our the A over the T formula, it becomes the A over the T is equals to 10 pi, which is the A over the arrow, times 0.4, which is the arrow over the T. Now multiplying them together, the A over the T will be equals to 4 pi, and the correct option is D. Our next question is from NECO 2002, and it states that when a stone is dropped in water, the radius of a circular wave is increasing at the rate of 0.2 meter per second. Find the rate at which the area is increasing when the radius is 0.07 meter, and we are giving the option. Now the very first information in our question is the rate of change of radius with time, which is the arrow over the T, and the value of the arrow over the T is 0.2 meter per second, and we are looking for the A over the T, that's the rate of change of the area with respect to time when arrow is equals to 0.07 meter. First and foremost, the area of a circle, since it's a circular wave, is equals to pi radius square, and our first call of duty is to find the A over the arrow, which is equals to 2 pi arrow. From our previous knowledge, the A over the T will be equals to the arrow over the T times the A over the arrow. Now we've gotten the arrow over the T to be 0.2 meter per second, and the A over the arrow to be 2 pi arrow. So therefore, substituting for the arrow over the T and the A over the arrow, the A over the T will be equals to 0.2, which is the arrow over the T, times 2 pi arrow, which is the A over the arrow. At this point, we are going to be substituting arrow for 0.07 meter as we are told in the question. So doing so, the A over the T will be equals to 0.2 times 2 pi times 0.07, and multiplying them, the A over the T will be equals to 0.088 meter square per second, and the correct option is D. Our final question states that the radius of a sphere is increasing at a rate of 3 cm per second. Find the rate of increase in the surface area when the radius is 2 centimeter. Now the very first information we are giving in our question is the rate of change of the radius, which is the arrow over the T, and we are told that the arrow over the T is equals to 3 centimeter. Next, we are told to find the increase in the rate of change of the surface area, which is the A over the T. That is, the A over the T is our unknown when arrow, which is the radius, is equals to 2. Now the very first thing we are going to be finding is the A over the arrow, because we know that the area of a sphere is equals to 4 pi radius square. Now differentiating our area with respect to radius, that is the A over the arrow, it will be equals to 8 pi arrow. That's why I'm depreciating a with respect to arrow. Now from our knowledge on the rate of change, the a over the t will be equals to the a over the arrow times the arrow over the t. Now we already know that the a over the t is unknown, the a over the arrow is 8 pi arrow, and the arrow over the t is 3 centimeter. Now substituting for the a over the arrow and the arrow over the t, the a over the t will be equals to 8 pi arrow times 3. Multiplying, it becomes the a over the t is equals to 24 pi arrow. Now we know that the value of arrow is equals to 2 because we were told when the radius is 2. Now substituting 2 for arrow, the a over the t will be equals to 24 pi times 2, which makes the a over the 2 to be equals to 48 pi centimeter square per second. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check our hidden facts further mathematics textbook. You can easily get the hard copy, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.